Recording in progress. Hello everyone, welcome back to our channel. In this video, we are going to discuss about the Docker. So, what is Docker and what is containerization? How we can how containerization helps to create the modern applications and how it will be very useful, right? So, if you are new to the channel, please do subscribe and like. If you have any suggestions for me, please do comment as well. So, what is Docker and a complete overview of containerization? So the biggest problem for any developer, so when you run our application, it works on our machine, right? So as a developer, if you create a like any any application, so it will work on our system. But when we send, like, when in the testing or in the production stage, it fails because of the like many issues. There will be like always versions will be different for the like people who are testing or who are in production who are testing. And for even for if a new developer onboards, so it will be like it takes many hours to set up for a new member or new to set up the environments, or different OS version will be there. In the OS versions, like with the testing team, it also fails there. So that is the main reason, the biggest reasons why we need containers. Got it? So Docker solves this issue with the containerizations, where will, in a simple terms, in the containers you can install all the dependencies and softwares. There you can easily run your applications. So once you have everything in the Docker, so even in the testing or in any, you just need to run one, create once, and it can be run anywhere. So here is the like we'll go to the definition which I have created. Like, Docker provides the solution, a universal package. Got it? Docker solves the work on my mission problem by packaging an application with all of its dependencies into a single standardizable unit, a container. It is called a container. So what we'll do, we'll install all the dependencies of the application, and it also works the operating system as well. So you can share with anyone of like, or your QA team, or in the production. So, and it also support all the cloud platforms as well. So package your application and its dependencies together, run it anywhere, on any machine, any server, any cloud. Guarantee the exact same behavior in any environment. Because see, previously, so when we were running on your local machine, so if like all the dependencies which you are have under your operating system, so it works on the same way. Okay, but now if you already have the all the dependencies on the container, so it can be like anyone, if he wants to run, or if he wants to use, it can be run on the same way, or it is the same behavior. So what exactly is Docker? So Docker is an open source platform designed to automate the deployment, scaling, and management of applications using containerizations. It provides a common toolkit for developers and system administrators to build, ship, and run any application anywhere. It's an open source platform, community driven, and free to use. Uses containers. So I'll also explain the container. So how containers containers create and all. So packages software into standardized units for development, shipping, and deployment. It's a lightweight. So containers share the machine's OS. So I'll also explain so how it can be shared the machine's OS, and how it will be different from the virtual machines. Machine's OS system kernel, and therefore are burdened by a full guest OS. So we are not using the complete operating system to run any applications. We'll share the OS. Since we are sharing the OS, so the complete OS won't be running here. That's the reason why it is very fast. Creates a consistent environments, eliminates inconsistencies between development, testing, and production. So that's the biggest asset of the Docker. The core unit, the Docker container. A container is runnable instance of an application. It is a lightweight, standalone, executable package of software that includes everything needed to run it: code, runtime, system tools, system libraries, and settings. So we'll have everything, like we have our code, we have all our dependencies, the settings, the libraries which we want as per our softwares. Like for Node.js we want different things, and for Java we need JDK, like for Python we need a different dependencies, right? So we'll have everything in the Docker container. So a running instance of an application provides a completely isolated environment for the application, shares the host machine's OS kernel, making it efficient. So since we are sharing the OS kernel, the host machine's OS kernel, so since we are sharing the OS, so we like it makes more efficient because we are not installing the operating system on every container, right? We're just sharing the operating system. There's a reason why it makes like more efficient and more fast. Starts in seconds, unlike the traditional virtual machines. This is very fast. So I'll also like have an example. Think of it like a packaged lunchbox. Everything you need for your meal, like app. So for app, everything what we want will have complete setup is pre packed inside the sandwich, the apple, the drink. Like we for an application we need a code, we need the dependencies and everything, right? You can open and eat it anywhere without needing a specific kitchen. So we don't need anything, like we don't need the plate or some separate dining hall or anything. So we just once we have the box, so we can open it and eat it anywhere. We can run it anywhere, just like that. So the blueprint, the Docker image. So this complete thing is a Docker image. Okay. So in the Docker we can create as many containers as we want. It's a blueprint of the complete application and dependencies, everything. So if a container is a running application, it is a running application. A Docker image is a blueprint used to build it. Okay. You cannot have a container without first having an image. Key characteristics: a blueprint for your application, a static unchangeable file with a executable code. Read only template contains the application code plus all necessary dependencies. Used to create containers, one image can be used to create many identical containers. Example of official images: Nginx, Node, Python. So here we can see the key differences. So how the Docker containers versus virtual machines. This is what we are discussing. So here we have, like, for virtual machines we will be having the guest operating systems, but in the Docker containers we won't be depend on the guest operating systems. Docker engine will take care of everything. The host operating system will be there, then the Docker engine will be taking care of everything. So virtual machines packages a full guest operating system, heavyweight, often gigabytes in size, slow startup time. Each virtual machine runs a completely separate OS. Docker container shares the host operating system kernel, lightweight, often megabytes, not a giga, not in a GB, just in a MB size. Fast startup time. Containers run as isolated processes on the host. Virtual virtual machines virtualize the hardware. Docker utilize virtualize the operating system. the hardware, which means the CPU and all. So virtual systems virtualize the CPU, the hardware which we are using in our home. But Docker virtual is a complete operating system. So how we our application knows, and how Dockerfile knows what our application wants. So see, you need to tell Docker, right? So what the dependencies you need, and how you want to run your application. So that's where the Dockerfile enters. So in the Dockerfile, you once your application is ready in the Dockerfile, you need to tell Docker that what you need, like you need Python or Java or Node.js. You need to tell that, like you need to write the Dockerfile in the specific format. So this is a format, like this is a basic format. So where you need to tell the Docker that I need uh, Python run pip install Flask. So yeah, we'll be running the installing the Flask application. Then the main file. Okay. So Dockerfile is a simple text file that contains a list of commands that Docker uses to assemble an image automatically. It's the automation engine behind building consistent and repeatable application environments. Core concepts: a simple text file with instructions defines all the steps to build a specific Docker image, automates the entire application setup process. The common instructions. So we'll be having multi-tier Docker files, like a Docker build image, Docker run, Docker build. So we'll be running different, like based on the applications. So we'll be using different we'll be writing the different type of Docker files. So these are common. So first, from specifies the base image to start with. Run executes a command during the build process. Copies files from your local machine into the image. CMD defines a command to run when the container starts. And we have the Docker Hub. So here is a like Docker desktop. So you need to install Docker desktop first. So here we can see the Docker containers, Docker images, volumes, and Docker builds. And here is the Docker Hub. Okay. So we can install what we wanted. So you can also install them. Fif- So Docker Hub, the registry for images. If you see, once you click on the images, all the images are there. Okay, these are the images. All the images are there. You can just click on install them. So Docker Hub is a cloud-based registry service that allows you to link to code repositories, build your images and test them, store manually pushed images. It's the largest library and community for container images. Key features: a public repository for thousands of container images, provides official ready to use images for popular software. So these are the ready to use. Okay. The GitHub or Docker push and pull images just like code. Examples of popular images on Docker Hub: MySQL, Redis, MongoDB. So that's many. And end-to-end Docker workflow. The Docker workflow is a continuous cycle of development, packaging, and deployment that ensures consistency at every stage. So once you have your application, then you will be creating the Docker file. Then you will run a command, Docker build command. Then Docker starts. Then you can uh, work on the like Docker run command to launch your application inside a new container. Then app runs anywhere. Once you run, app runs anywhere. Like push your image in or to a registry and pull it to run on any other machines with Docker. And what is where is Docker used in the real world? In the real world, all the software development in all the software developments of applications or any type of application, Docker works and solves your problems. So in web applications, microservices or cloud deployment, CI/CD, Kubernetes, it works everywhere on the software development side. So why should you use Docker? So faster deployment, package once and deploy in seconds, drastically reducing time to market, consistency across environments. We have discussed this, and easy scaling. Spin up new containers to handle increased load with single command. So lightweight footprint, run more applications on the same hardware compared to the virtual machines. Developer friendly, simplifies local deployment and onboarding the new team members. It is very easy to use, maintain. So see, we have many advantages, but you can't implement Docker on each every application, right? So consider alternatives when developing very small applications or scripts. Running applications with heavy GUI, while possible, Docker is optimized for server-side command line applications. Use simple self-contained local tools. Using simple self-contained local tools, if a tool has no external dependencies, like we if a tool or application it don't want any dependencies, then you're like you don't need to run Docker, right? So is only used on one mission. Docker may be unnecessary. Key takeaways: Docker and containerization, it's a leading platform for creating and managing containers, images to containers. Images are the read-only blueprints. Containers are the running instances created from them. So containers are created from images. Portable and fast. The primary benefits are building once to run anywhere near instant startup times. And industry standard, a foundational skill for modern developers, DevOps, and cloud computing. So that's about the Docker, the complete overview. So how it runs, how containerization helps, and how it differs from the virtual machines, and how we can write the Docker basic Docker file, and what are the its advantages, and when to use the Docker and when not to use the Docker. So we have gone through a bit overview. So I hope like this helps a lot. You can just go through this video, you'll have a basic overview of the Docker, how like what is Docker and all. So in the next class, if you comment, so I can also work on the simple Docker files where we can run simple Python applications or Node.js applications or Java applications. And I see sometimes what happens, even simple applications, if while we are adding the dependencies, so maybe like Docker also consumes more energy, more memory, sorry. So how can we reduce that memory? So these all things we can learn. So just like and subscribe to our channel and comment below. So Docker hands-on tutorial. If you want to see a practical coding tutorial next, please do comment. And that's it. Thank you so much. And if you found any mistakes, so you can also comment that. So I'm welcome to hear your opinion on the video, and this like new journey for me. So I hope you'll support. Thank you so much. Bye bye.